In 214 number 3, we've got two capacitors connected in parallel up here. You can see it, the top end of this one is connected to the top end of this one, and the bottom end of C1 is connected to the bottom end of C2 by nothing but straight wire. So the two capacitors are in parallel with each other. They're connected end for end, and we can replace that parallel combo with a single effective capacitor. I'll call it CP. Where capacitors in series add to give the total effective capacitance. So this will just be C1 plus C2. So I think I'll finish the drawing and then we'll go ahead and calculate that. This is still C3 down here, which is given as 48.0 millifarads. Alright, then CP is going to be 18 millifarads. Plus C2, which is 14 millifarads. That adds up to 32.0 millifarads for CP. And then at this point we've got two capacitors that are in series with each other. Okay, one end of one capacitor is connected to one end of the other capacitor with nothing growing out of the middle. We couldn't say that up here. This kind of looks like it might be connected in series with that one. We got the bottom end of this one connected to the top end of this one, but I got something connected to that middle point. Something growing out of the middle is my slang expression for it. So these two are not in series. Here they're connected to each other, and there's nothing else connected to that wire that connects the two capacitors together on one end, so they really are in series. So the effective capacitance between here and here of this system is going to be this effective capacitance, which takes into account the fact that these two are in series. I'll call it CT for the total capacitance. CS would have been another natural name, maybe C123, since it is the effective capacitance of three capacitors. But capacitors in series add reciprocally to give you the reciprocal of the total capacitance, where the total capacitance is the reciprocal of the sum of the reciprocals of the individual capacitance capacitors making up that series capacitor. So that'll be 1 over C3 plus 1 over CP. Or CT is 1 over 48.0 microfarads plus 1 over 32.0. I said micro, that's milli times 10 to the minus third farads. Millifarads. And that yields 19.2 millifarads. And that's the answer to SAC 2.